Okay, we'll be getting started in just about a minute, so we're going to let the rest of the guests in, and we'll get started. Okay, it's 2:30, and we are going to begin our next session, the final one for today. I'm Marcia Connett, and I want to welcome you to Making Numeracy Make Sense. It's being sponsored by Wisconsin Literacy, and we're a nonprofit statewide coalition of 70 literacy agencies. We strengthen literacy statewide through expert trainings, personalized consultation, health literacy, workforce connections, and advocacy. With me today is Anna Beer. Anna's running the controls behind the scenes. She's our Northeast Regional Consultant. And with us today is Amy Copps. Amy is a lifelong learner who enjoys working with students. She has had the pleasure of teaching preschool through adult learners for more than 25 years in a variety of educational settings, from graduates on down, and is gotten her bachelor's degree in elementary education with a minor in mathematics from UW-Platteville, and is enrolled at UW Superior, getting her master's degree in instruction. She is an ABE, GED, HED instructor at Lakeshore Technical College, and we are very happy to have her with us today. So Amy, take it away. It's all yours.
Thank you so much. It is a pleasure to be here. I would like just to take a moment to say hello. Just give a wave. I'm in my classroom in Manitowoc. So it is a pleasure to be here with you today.
You are welcome to use the chat box. Excuse me, Amy, I forgot to say this. You're welcome to use the chat box if you have questions along the way, or you can raise your hand and Anna can unmute you if that's the way you want to go. So once again, Amy, it's all yours, I promise.
Thank you so much. So welcome to this session on Making Numeracy Make Sense. When you registered for this session, you were emailed handouts. I'll be using the handouts in the session today, the PowerPoint you were provided, and a booklet as well. And so let's begin thinking about the key to learning. So the key to learning for students is going to be moving them from short-term memory, moving that learning from short-term memory into long-term storage. And in order to do this, what we want to do is we want to help students make sense of what they're learning. It needs to be meaningful. So for math, in our daily lives, we want it to be relevant. I'm hoping to do that today with you by sharing a game, hands-on activities, and strategies in math. Overall, math definitely takes practice. As we work through the materials, I have provided a booklet. The booklet has 110 pages, so I didn't have you print that. That booklet is a resource for you. I've shared all of my documents that I use in my Math Level 1 class. Since it's in the Word format, you are welcome to revise that booklet to meet the needs of your learners. So the first concept we're going to take a look at is place value. Thinking of our English language learners, when they're working with numbers, they actually read the numbers in their own language and then translate them to English. It's important for with all learners, we practice how to read numbers aloud. And even as a math teacher, I took this for granted. When my own children were learning to read numbers, their teacher pointed out that each comma has a name, and the commas have a purpose. for the ease of reading numbers. This was just something that I did automatically. And so as a teacher, I needed to kind of retrain my brain and spend time with my learners going through how to read numbers aloud. And another thing that can be confusing for students would be the commas and the decimals. So spending time to explain their purposes and how we can utilize those. I will be switching from the PowerPoint to my dock camera so that I can share the handouts. So this is my document camera for my classroom, and it'll give me the ability to share the documents and work through them with you. So I'm taking a look at handout number 1. It is a simple place value chart, but this chart provides us the opportunity to teach some important things with our learners. The first thing I like to do is show the students where the commas go. So I add in the commas, and then I talk about place value and each period. Our number system is broken into periods, the groupings of these 3 place values, the first one being the ones, then the thousands, millions, and billions. And the commas really help us in reading the numbers aloud. I also like to point out to students that math is made up of patterns, okay? So here's the ones place, and this is the ones period. Here is the thousands place, and that is the thousands period. Millions and billions. Another pattern we can see in the place value chart would be the repeat of words. Our middle column in a period is the tens, and then the 10,000s, 10 millions, and 10 billions. Finally, the last column has the hundreds, and then 100,000s, 100 millions, 100 billions. And as I share with my students, I didn't think that I would ever see in my lifetime trillions, but I have, and I even read something last week about quadrillions. I don't know beyond quadrillions. And so practicing reading of numbers and the importance of the commas, we read within the periods. This is a grouping. So we read 103. And then for this comma, we say 1,000. 103,000. 274. With this, I have a game to play for place value. I'm going to share the game next. It's a simple game. It takes a deck of cards. It can be played with 2 or more players. Before the game begins, you want to determine how many places for each player's cards. I'll be demonstrating the game, and for today I've chosen 3 places, the ones, tens, and hundreds places. Simply
Amy?
Yes.
Sorry to interrupt. This is Anna. So before you move on, could you explain, we have a question. What do you mean about periods on the whole numbers chart? You mentioned commas and periods.
Yes. Thank you. Thank you for the question. Periods, periods on the place value chart are the groupings of the 3 place values between the commas. So the ones, that's considered a period. the thousands, these three place value columns is considered a period. Millions and billions. And so it's important to point out to students that we have the groupings of the three columns here. And these three, the ones, tens, and hundreds, make up the ones period. The thousands, 10,000s, and 100,000s make up what's called the thousands period. And it continues on, millions, billions, and trillions. So definitely let me know if that helps or if we need further explanation.
We have a follow-up question.
Yes.
Why use the word period? Is there a math connection to that word? I have called them groupings.
Groupings works as well. My math language, so thank you, yes. My math language has just been periods when I've kind of studied place value, but groupings, absolutely. It has the same meaning. And the important part is going to be just recognizing that we have those three columns in each grouping or each period, and then just showing how the pattern repeats. So absolutely, grouping would be the similar term.
All right, we have a couple thank yous to that. Thanks, Amy.
Thank you. So then taking a look at a simple game with a deck of cards, 2 or more players. Determine the number of place values. I've chosen 3 today. And then each player takes a turn drawing 1 card at a time. And for this game, I've set that our goal is creating the highest number possible. And so I do give students in my classroom kind of just blank pieces of paper, and then we mark 3 place values. We can definitely write in then ones, tens, hundreds. I start with 3 place values, but as we progress, we play the game with 4 place value spots, 5 cards, 6 cards, and so forth. So I have just 3 random cards here. I haven't looked at them yet. I'm going to pick the first one, and it is a 9. And so students get to use some mathematical reasoning. If I'm trying to make the highest number possible, you know when a student picks a 9 because they're like, yes, and it's the first card, I know I'm going to put it in the hundreds place. And then the other students in the group take their turns, and it gets back to me. I draw a 2. So I have to decide, do I want to put the 2 in the tens place or the ones place? It begins with like beginning probability. And I'm thinking my last card is probably going to be higher than a 2. And so I place the 2 here. Now with the deck of cards, important to note, I took out the aces through 9s to run 1 through 9. I haven't figured out the zeros yet. Depending on the level of my students, I might use a 10 for the 0. And my last card is a 4. And so then the next step, we take time to practice reading the numbers out loud and reinforcing place value with the 9 in the hundreds, the 4 in the tens, and the 2 in the ones, the 942. Any questions on the game?
I do not see any questions.
Okay, thank you, Anna. And so,
oh wait, something popped up.
Okay.
Please repeat what cards you keep.
So when all I do is I just set a deck of cards in the middle of all the players, and students pick, oh, I see what you mean. My apologies. I pick ace through 9. Ace through 9. Ace being the 1. And then, so this is the deck of cards. I just keep ace through 9 in there. I shuffle them. The cards go in the middle. Students pick them one at a time. Aces stand for the 1, and 2 through 9 are for their numbers.
Thank you.
The next thing that we're going to take a look at would be keywords. Keywords in math. So for problem solving, one of the things that I work on with students is building vocabulary, really spending time to work on vocabulary because it'll improve our problem solving skills. And then the strategy that I start out with students is that we highlight keywords and we break story problems apart for a better understanding. And so page 2 of the handout, I have shared an activity that I go through with learners. I call it the math symbols and meanings. Here we go. In the classroom, what I do is the students are given this sheet, and then they're broken into small groups. If, working with a learner, can participate in this with a learner. There is a word bank on the bottom right. These are common math vocabulary words. The nice thing is you have a copy of this as a Word document. So what you can do is you can go in to find this in the booklet, and then you can change the word bank to meet the needs of your learners. The class that I teach right now at Lakeshore Technical College is Math Level 1 for our GED HSED 509 program. And so the goal of the activity is to take each word from the word bank and place it in the appropriate symbol. If it means addition, subtraction, multiplication, division, or equals. On this page, I also have some notes for my students. I kept them here, but you definitely, depending on the level of your learners, you could keep them there or take them out. But in math, we often, when we're moving from early elementary then into middle school, multiplication changes because the x moves from multiplication as an operation to a variable in algebra. So I talk about the parentheses and how they mean multiplication, how an asterisk can mean multiplication, or a bullet point I've seen used as multiplication. I'm going to share the calculator I use in my classroom. If I type in 6 times 7, an asterisk shows up. And I find this very interesting on the calculator. The asterisk shows up here, but we had to press the X for the times sign. So I'm going to give you just a moment if you want to take a look at the word bank. Kind of think about where you would place the vocabulary words. the students in my class, in my math class, tend to be adults that are working towards their GED or HSED. And so they have a varying degree of math levels. So during this activity, I enjoy listening to the students share their thoughts about the word bank. Some of the words for me are very easy to locate which symbol they go with. So when I look at add, that one is easy for me. And the word altogether, if I put things all together, that is another common word that I recognize means addition. Decrease, something goes down, and then generally that means subtraction. Just last week we started our semester. I started with this activity, and one of the groups was talking about the word difference. And a student shared, well, I think it means subtraction. I don't know why I think this. She says, it's just something I remember from high school. It's a great conversation. And I definitely agree with the student. There are some words on this list, same thing. Can I give an explanation for difference? Difference is one of those that is more challenging for me. Why does it mean subtraction? I do try to make up simple problems. So I use the example, one of my daughters, Sarah, had $20. My other daughter, Megan, had $5. What is the difference in the amount of money that they have? And so as soon as I said it in that question, what is the difference between the amounts that Sarah and Megan have? Right away they said 15, and I said, okay, how did you solve that? Oh, I guess I subtracted. So difference, by putting it in those words, I can help make that connection to subtraction. And I'm always honest with students. I'll be honest with you. Divisor. Divisor, to me, it starts with the word division, and I know it is related to division. So I just point out the beginning of it starts with the word division, and the divisor is part of the division problem. Now, granted, today we just have an hour together, and I'm covering kind of 5 different math concepts, so I'm moving along much faster than in the classroom. Like, I spend a good hour to 2 hours on this activity with students, but I'm kind of giving you the modified version here today. So double. Double tends to mean multiplication. If we double something, we times it by 2. In class, I do spend time talking to students about addition, because if I have $5 and I double my money, I have 10, I could solve that by 5 times 2 or 5 plus 5. So in class, we spend that time making the connection between addition and multiplication. That multiplication is the shortcut for adding. Equal. Fewer also means less, and those are subtraction. Half. If I cut something in half, I divide it. How much more? How much more? This is something I've added in. It tends to be a popular story problem. And how much more? Usually we're using subtraction. So that's just something I added in myself. And it's nice to make this sheet of notes for students to refer back to. So I could go back to the story problem of one daughter, Sarah, having $20, Megan having $5, and I can ask the question, how much more money does Sarah have? How much more means to subtract. Increase means to go up. That's generally when we add. Then we get to the word of. Of. In math, of usually means to multiply. And I share with the students, I'm unsure why. In my classroom on the board, up in the corner on my dry erase board, since we moved into this building a year and a half ago, I have the words that say of means to multiply. Per. We're finding miles per gallon, miles per hour, average per month. That's going to be division. Plus is addition. Then moving on to product. Product was another one where my student shared with her group. I don't know why I'm thinking this. She said, product means to multiply. And she is exactly right. So as my students take notes, I always encourage them, highlight the ones that you might not remember. Bring attention to those. As you refer back to this page, page number 2, these notes, when you're working on story problems, it'll help us remember our vocabulary words. Quotient means to divide. And that's another one of the vocabulary words that we highlight. Same as means it is equal. Split up, to divide. Sum means to add. I always share that early on I had to know my vocabulary in math as a student as well, and so sometimes I had to memorize things. And what I did was sum has 3 letters and the word add has 3 letters. And so as I share these examples, then other students in class kind of share those associations they've made with words. Takeaway is subtraction. Times is multiplication. Twice is also multiplication. It has the same meaning as doubling. And then yields. Yields means to find, it means equal. To find the answer.
Amy?
The nice thing, yes.
Oh, I'm sorry. I have just two comments coming in.
Yes.
One is just going back to you showing the calculator, that's a good point about the asterisks and multiplication, and that this person said she uses it all the time and never been able to think about it being a possible barrier. So we're appreciating that. And then someone asked, could you give an example of as multiply?
Okay. I'm trying to think of a simple. My first reaction is like 2/3 of the class is going on the field trip. Okay, so if we have 2/3 of the class going on the field trip, and we have 24 in our class, 2/3 times 24. And that's going to equal 16. Without getting into fractions, that'll, and actually the interesting thing about fractions, because my course is made up of whole numbers, fractions, decimals, percents, and then we get to positive and negative numbers in a semester. And a couple of years ago, I asked our dean, I said, you know, I've been helping in the welding math classes, and they use a calculator. I said, it takes me about 6 weeks to get through fractions alone, and I'm not sure students are retaining it. And so in our classes, we do allow the calculator. And so by the second chapter, the second unit, they're practicing using the calculator. So 2/3 of something, we would take 2/3 times that number.
Thank you. I don't see any other comments right now.
The idea I have also with this page and the workbook that I share with my students that we work through in the workbook that you have a copy of is that this kind of becomes their page where they take notes. So as they learn something, but it's not something they can keep fresh in their mind, they jot it down, but then they know right where to go back to look that up. The next page of the handout, I have a little bit of problem solving. But before I share the problem solving, I am going to share this PowerPoint and just kind of talk about problem solving. With problem solving, we know that we want to practice. And what I recommend is repeating problems, not repeating the same problem, but repeating the type of problem, okay? So for instance, in my math course for the semester, I repeat story problems from units 1 through 5 that cover money, utilities, payments, wages, perimeter area, construction, miles per gallon, miles per hour. And so then in each unit, I come up with new story problems, but they're practicing the same skills to give students that time to practice and try to retain how they're solving the problems. And I try to make them as relevant to the learners as possible. So in my first unit of problem solving, we take time and as a class, we talk about the checkbook. And we talk about, okay, what are the additions called in a checkbook? So in a checkbook, when we put money in, that would be called a deposit. And then when we take money out, we're going to subtract from our checkbook, and that is called a withdrawal. So even before we look at problem number 1, as a class, we're brainstorming different types of deposits. It could be my paycheck. If someone owed me money, I use my children as examples all the time, so that my daughter has to pay me for her cell phone. She doesn't have a checkbook. I pay the cell phone. So money that is given to me. And then we go through our withdrawals. We can make a withdrawal by writing out a check, using the ATM, using our debit card, automatic withdrawals, for instance, for loans. And then just last week, it was great. One of the students said PayPal. Oh, and actually we didn't put PayPal there. They brought up PayPal, Apple Pay, Samsung Pay, and Venmo. And so it's new for me because I don't trust my phone with these items, but great that my students are talking about it. So we actually put those in the middle. Because as we take money in, my daughter does this. She pays her monthly bill actually through Venmo to my husband because he has it set up on his phone. That is a plus for us, but that is a subtraction for her. So we distinguish deposits and withdrawals, and then we begin looking at the story problem. And as you'll notice throughout the presentation, I definitely have highlighters. I have highlighters for students everywhere. I use highlighters all the time because it helps me focus. And so for this instance, I talk about deposits and that I'm going to highlight them in yellow. And the withdrawals, I'm going to highlight in orange as we read through the problem. We talk about balancing the checkbook, and I find it interesting. When they do take a unit test for me at the end of Unit 1, a couple of students, they actually forget this first beginning number. They forget about the money that's already in the checkbook. So we have to remember that the checkbook has a balance. That means that money is in there. It has been deposited. So that is a plus. And then we work through each part. Sam has written out a check. We talk about, okay, if you write out a check, deposit or withdrawal. That one is a withdrawal, and this one is a withdrawal. So we color code that with the withdrawal, and I put the minus sign there. Sam has a paycheck deposited. Deposited means money is going in. That is a plus. Another check is written for rent. That's going to be a minus. That is a subtraction. And then money is withdrawn from the ATM, and it wasn't my bank's ATM, so I was charged a fee. So we talk about that as well. And then the neat thing in math, there are actually a couple different ways to solve this. I always, I'll demonstrate a way to solve it, but I talk to students, have them share ways that they've solved, and then it's my goal, if a student isn't coming up with the same answer, then to look at the student's work and see where the student has made mistake and help the student in the steps that they're taking to solve the problem. This is definitely a mind shift I've had over the years for teaching math, that especially working with adult learners, they have these steps in place. Maybe they're not getting to the right answer, but rather than trying to teach them my way to solve the problem, I need to look at what do they know and what can we work with to get that right answer.
Amy, there's a comment.
Yes.
The comment is many checkbook registers and reports still use debit for withdrawal and credit for deposit.
Yes, yes, that would be a great thing. Excellent, thank you. That is a great suggestion to bring into the vocabulary. Thank you. Then throughout the workbook, for the next one, it's the number of visitors that have visited Blue Harbor. So we know that we're going to add all of them. I do recommend to students highlight those numbers. It's easy to miss a number. And then how many people visited the Blue Harbor Resort altogether? So throughout the story problems, I try to bring in those vocabulary words so that they get practice and recognize and learn the words. And same with number 3. How much more money? How much more? Keywords for subtraction. Juan has saved $710 for a down payment on his car. He has found a car to purchase that costs $3,050. How much more does Juan need to buy the car? Any questions with the problem solving strategies?
While we wait to see if any questions come in, someone said, thank you for the workbook. It is very useful.
Please feel free to revise it. That's what I love about the Word document. That's what I love about no copyright. You can adjust it as you need, and you can print the parts that you like. Just from a sidebar here, last March, we returned from spring break on a Monday, and we found out that we had a week to have our classes virtual online. So in about 2 hours, I put together the workbook because I thought, whoa, normally my students meet with me in the classroom. I can hand out these sheets. In my classroom, everything is as hands-on as possible. And so it is my work, so my apologies that you will find errors. I have tried to keep track of them as I discovered them this fall and made corrections to them.
Okay, there are a couple comments and questions here. So one is about the access to the recording and the workbook, and I can answer those questions. The recording and all the materials will be on our website under the for the winter conference, and I'll put a link into that in the chat in a moment. If I did try to send the materials out to everybody ahead of time, but there might have been some issues with registration or people registering after I sent those out. So if you did not get the materials ahead of time, there should have been 3 attachments you received. If you didn't receive those will be on the website. And again, I'll put the link there. And another comment, thank you. That is very generous of you to share, Amy.
Oh, absolutely. Absolutely. My pleasure. And I know I'm covering a lot. I was kind of trying to cover 5 different topics in a short amount of time. So if anything is confusing, you have questions, at the very end of the PowerPoint, I do have my contact information. Feel free to send me an email, a text message, or give me a call. My cell phone and my email are there, and they're both for work. My LTC email, and I have a cell number that I use for work. So feel free to reach out to me with any questions, or if you're working through the booklet and something doesn't make sense, absolutely. Feel free to reach out to me. And as I tell my students, I'm not a traditional normal math teacher. I did study math in college. That was, a while ago. And over the years, my philosophy has definitely changed on my approach to teaching. And by no means am I the expert. Instead, in the classroom, I am a learner with my students. Absolutely. I learn so much from my students. The next activity.
There's one more comment before you move on. Someone wrote, I've had a student not connect with the number 3 problem, so we set it up as addition problem, since that's how he thought about it. We had a conversation about setting up the problem that made sense. Maybe this made sense. This made sense to him, and we talked about opposite operations. So it looks like just explaining some flexibility and adjusting problems to be a way that makes sense for your learners. And also writes, great material, very useful. Thank you so much.
A fantastic point. Absolutely. Kind of what I was, very nice job explaining. Kind of what I was trying to, in the classroom, I definitely open it up that students can share how are they problem solving? Students learn so much from each other on how they go about solving a problem. And absolutely, because there's two different ways for number 3. We can just add and subtract, or we can take all of those subtractions, all of those withdrawals, and we can add them up and take it away from the balance. So absolutely, I stress to my students all the time about there's definitely more than one way in math to solve problems, and I want them to share what they've learned, and that's where I've learned probably the most in my math experience is from students. The next activity I have goes into area. We start with talking about what is area, and that area is a flat filled in space. We brainstorm ideas about where do we use area. We use it if we're replacing the flooring in our house, if we're painting, replacing shingles or vinyl. If I'm planning out furniture, I can use area for that. If I'm trying to figure out what size rugs I want, definitely a lot of uses for area. And so what I do for area is simply graph paper. I use graph paper, and I start with the square. And I talk about, the square, the graph paper. These are all squares, meaning that all the sides are equal to each other. And so I just write the word square. We talk about the 4 equal sides. And then I shade in 1 square. And I ask them how many squares are there. And to begin with, they kind of give me that puzzled look, like, is she giving us a trick question? They're like, Amy, there's 1 square there. I'm like, exactly, there's 1 square there. And then we color in the next one. And this time I have them color in this square here. And wherever I can, I try to have the students discover things. So if they discover it, it means it's making sense to them. They're more likely to remember it. Then we draw in the next square, and I don't really tell them anything. But then as we're moving along, some students kind of start catching on, and they definitely share with class. So there's 1 there. I've shaded 4 squares here, 9 squares here, and we continue on. I usually continue on. I do a 4 by 4 square, a 5 by 5, and then we talk about area. 1 square here, and then this is a square, and inside of it, it's made up of 4 squares. So this area is 4. And then this square here, the area is 9. And there are 9 squares in that. So that's where we talk about area, help them to discover the formula for a square. This side here is a 1. This side here is a 1. And 1 times 1 equals 1. This side here is a 2. This side here is a 2, and 2 times 2 equals 4. 1, 2, 3, 1, 2, 3. 3 times 3 equals 9. And so something that I share with my students is that in class, what we want to do is we want to be able to explain how to figure something out or why something takes place, rather than just memorizing formulas. It's interesting to me, growing up, yes, math was easy. I learned it quickly, but if you had asked me why something was, why is the formula of a square side times side, I wouldn't have been able to explain. Why is the area of a rectangle length times width? I didn't know why. I could just solve the problems. So when I became a math teacher, I struggled as a math teacher because I just knew it, but I didn't know how to explain it or help it make sense to the students. So I found that through as much hands-on and discovery for the students, that this is area. It's flat and it takes up a space. That if we take this side times this side, we get the area. This side times this side, we get the area. And that a square, we call them sides because they have the exact same measurement on all four sides. Then we look at the rectangle. And now they kind of have the hang of it. And so we just pick ones to draw. They might not know the formula right away, but they catch on to what I've done. We kind of make different shape, different rectangular amounts, I should say. Still rectangles. And then we can also talk about, okay, how come with area we use the label square units, square units. And so we can talk about, well, area, there's one square in there. This square, there are 4 squares here. There are 9 squares here. Let's take a look at rectangles. Within this rectangle, inside of this rectangle, there are 2 squares. This rectangle is made up of 2 squares. That side there equals 1. Here, this equals 2. We discover 1 times 2 equals 2. It is the shape of a rectangle by definition, and inside of it, its area is made up of squares. So that's how we get the square label. And same thing here, inside 1, 2, 3, 4, 5, 6, 7, 8. We have 8 squares here. What is the length of this rectangle? 4. This would be called the width. 2. This rectangle that measures 2 by 8, 2 by 4. 2 times 4 equals 8, and it's going to be square units because it's made up of squares inside. The last one that I have as an example here, 3, 6, 9, 12, 15. They can count. There are 15 square units. And it measures 1, 2, 3. And then 1, 2, 3, 4, 5. And the 3 times 5 equals the 15 square units. In the booklet that has the 110 pages, I do provide practice problems throughout the booklet for area. There's a project 2, carpet the house, on pages. So I'll put area in case area interests you. I'll put this here to help narrow your focus. These are the pages that have particular activities for area. Any questions with the area? As you continue looking in your handouts, and I also provided this in the PowerPoint, the formulas. I meant to get to the triangle. The triangle is kind of interesting because triangle is half of a rectangle. So we spend time with that, taking rectangles, cutting them in half, and discovering the formula. But I do have the page numbers here for additional area activities. Then continuing on, the next strategy, Unit 4, with my class. And notice up here, it says page 67. That's to help you find this particular page in the workbook faster. Proportions. I definitely use proportions as a problem-solving strategy. My favorite problem-solving strategy is drawing a picture. My second favorite problem-solving strategy would be setting up a proportion if I can. And so proportions are made up of equivalent fractions. And to solve a proportion, we multiply diagonally. So we talk about what does the word diagonal mean. We multiply diagonally 30 times 2, which is 60. And then we divide by the remaining number. So I draw an arrow to that remaining number. And 60 divided by 12 equals 5. So the missing number is going to be equal to 5. And it starts setting us up for that pre-algebra for the next course as well. We talk about now the 14 and the 27, the diagonal is in the other direction. It's still considered a diagonal. So we multiply that. And I am going to use a calculator. So that's 378. And we divide by that remaining number. With each of these numbers, I have moved the variable so that the students come accustomed to that variable moving and that it's not always in the same location.
Amy, we do have one more question.
Yes.
We actually have two questions. Another one just came in. Do you ever teach proportions by using graphs?
Interesting. A colleague of mine just sent me something over break about using graphs to teach proportions. I haven't had a chance to look at it yet, but I do look forward to looking at the resource that she provided.
And then one other question, do your students use a calculator at your level of math?
Yes, yes. The GED test, the first 6 questions, students are not able to use a calculator, but after that they are provided a calculator. And for our 509 classes, we do have our 509 HSED classes, we have it written in that students can use a calculator. And so when I think about covering whole numbers, fractions, decimals, percents, and positive and negative numbers in 15 weeks with adult learners, we are dependent on the calculator just because of our time constraint. But what I do offer to students, and usually a couple each semester are interested in this, I will meet with students individually to go through longhand with them if they are interested in longhand multiplication, division, fractions, and decimals. I'm just going to share with you one proportion problem for problem solving. And in an office cabinet, the ratio of pencils to pens. Pencils I highlight in yellow, pens in orange. The ratio is 9 to 10. Prior to this problem-solving activity, we do study ratios. The ratios leads into proportions. We tie it together with problem-solving. If there are 117 pencils, so I look pencils, I'm working in yellow. Find the number of pens. And so for me, for problem solving with proportions, the key would be our labels. Our labels, I start with the labels and they help me to figure out where do the numbers go. So I start with pencils as the top here and pens as the bottom label. I have them draw an equal sign in. Draw a line here, and so we've already studied fractions, but right away some of them start to say, fractions. This label here is pencils, so I put pencils on this side. This label here is pens, so I put my label pens here. So often students have shared with me, I just don't know where numbers go, or if I know I need to multiply and divide, but I don't know which ones in what order. So I let the labels guide me. Yellow is the 9, so there are 9 pencils to 10 pens. 117 pencils. I can find the number of pens. With my students, I put the question mark, but I definitely talk about that we could put a letter there as a variable. That is that pre-algebra skill. For my learners, they tend to recognize the question mark a little bit better, but I'm like, you can put an A, B, C, you can pick a letter from the alphabet there. And then we follow those same steps. We multiply diagonally. 10 times 117. And divide by the remaining number. So we find out that our answer is 130 pens. In the problem solving, I do have it set up so sometimes the bottom number is missing, sometimes the top number is missing, sometimes maybe over here the number is missing. Any questions on the proportions?
There is one question that's asking, what level of students do you teach? Do you work with all levels? You know, the ELL at the lower levels? What ones are you teaching right now?
Absolutely. Right now, the math class I have, I would call a math level 1. We have a crazy name for it. We call it pre-college math. But for me, it's math level 1. It would be adult learners. Typically, if you're familiar with the TABE testing for math, it's about a TABE level 2 or 3 for math. And we have a nice, diverse group of students. What we do with our 2 departments, our ELL department and our ABE, Adult Basic Ed department, we have created a pathway. And so our ELL students, when they are ready to join one of our 509 classes, it could be to earn a high school diploma, it could be to build their math skills. Our math level 1 is one of the first classes that they come into, that they transition. We are a shared program, so many of our ELL, most of our ELL learners that want to take like the math level 1, they are also taking ELL classes at the same time. So it's like co-enrolled in both programs. So when students, ELL learners do choose to take an ABE course, we still have them working in that ELL classes as well. So we are like a shared program. So right now, typically I probably have about 1/3 ELL students, maybe 2/3 ABE students in my math classes.
Okay. Anybody else have other questions? I know we're a couple minutes over.
Yes.
Yeah, we want to take advantage while we have. This was wonderful. I put in the chat, I wish you had been my math teacher, because I grew up with horrible math anxiety because I just didn't get it. And you have clearly made it so simple. It's really terrific.
The neat thing is learning from the students. That's my absolute favorite part. I don't call it teaching anymore, even in my language in the classroom. And I share with them, I'm not the expert here. I'm like, no, because the math teachers, I didn't understand. I got to a point in math where I didn't understand, I'm a learner with them. That is my goal, to be a learner with them. I have great respect for adults that can work in like the calculus classes. I had calculus in high school, but honestly, I memorized it. I didn't understand it. Someday I'd love to go back and I'd love for someone to explain calculus. Yes, I took it. Yes, I got a passing grade, but I honestly didn't understand it.
Yeah, I kind of feel that way about geometry. Thank you. Well, this was absolutely phenomenal, and I can't begin to thank you enough. And thanks to all of you who joined us today. We are so pleased that you attended with us. Again, you made this so easy to understand, Amy. It is absolutely phenomenal. And if you want to join us tomorrow, we will begin our winter virtual conference at 1 o'clock with the Wisconsin State and Regional Economic Trends with Scott Hodek. It should be fascinating for anybody who's following anything along those lines. So we'll open up again tomorrow about 1 o'clock. We thank you for attending, and if you enjoyed the session today, please join us for that big share that you've been hearing about coming up on March 2nd. It's our online fundraiser that makes these kinds of programs possible. So again, thank you so much. We'll see you all tomorrow.